Hello and welcome to the another session of number systems. In this session, I am going to deal with exercise 1.1, but before starting that exercise, let me give you some idea about rational numbers, more rational numbers and the application of the rational numbers. We have defined rational numbers in the last session, but there is another question arises. Between two rational numbers, if I will write this is a number line, we are just going about number system. This session we are dealing with. So here, if this is a number line, this is 0 here, this is 1, this is 2. Let's say I have a number here, I have another number here. Let's say I have a number here which is represented by, let's say it is 3 by 2, and here I have another number which is 5 by let's say I have here 15 by, let's say 8. These are the two rational numbers which are here, A and B. Is there any other rational number between these two? Yes. The answer is yes. This is a number, this is a number, this is a number. How many rational numbers are possible between any two rational numbers? The question is, how many rational numbers possible between two rational numbers? The question is, how many rational numbers possible between two rational numbers? The answer is infinite. There is not one number, there is not two numbers, they are infinite numbers. If these are the two rational numbers A and B, there is a rational number here C, there is a rational number here D, and between C and D there is a rational number E, between C and E there is a rational number F, and like this we have infinite number of rationals between any two given rational numbers. So we are going to know the number of rational numbers between them. We will be given a question. What are them? What are the total numbers of rational numbers? If I will give you, find any three rational numbers between A and B. Let's say this is a rational number A, this is a rational number B. Find a number between A and B. So between A and B, on the concept of average, we normally calculate the rational number between any two rational numbers. The average of, for example, what is the average of mine age and your age? Let's say whatever your age is. Your age is, let's say 15 years, you are of 15 years. Your age is 15, my age is, and I will add these two ages. Let's say 15 is yours, 35 is mine. 35 plus 15 comes to be 50. And what is the average of 50? It is 25. So 25 lies between 15 and 35. So it is lying between these two. Okay. So since it is lying between these two, what is the number between them. So with that average, I will have another number C, which can be represented as A plus B by 2. This is another rational number between these two rational numbers. Similarly, a rational number between A and C will be D, and it can be represented by A plus C by 2. And between D, another rational number is E, which is represented by C plus B by 2, and so on and so on, so on. We can have how many rational numbers we need, we can find out that type of rational numbers. So this is one of the way in which we try to find out as many number of rational numbers between two numbers. Moreover, we will try to find out the rational numbers with the concept of making denominators same. What is the denominators? Same. A fraction number, if it is A by B, so A is a numerator and this is the denominator. So we make these denominators of all the rational numbers same, and then we find another rational number. How? Should I give an example of this first one? Let us take an example of this. Find 3 rational numbers between 3 and 4. So the first is here A is given as 3 and B is given as 4. So the first one is A plus B by 2, which is 3 plus 4 by 2. It is 7 by 2. The first one we have. The second number is A plus C by 2. We have A is 3 plus 7 by 2 and divided by 2. I will add them. It will be 6 plus 7 by 2 divided by 2. I have 13 by 4. That is the second one. And the third one, I have C plus B by 2, which is C is given as 7 by 2 plus 4 by 2. It is nothing. It will be 7 plus 8 by 2 by 2, and it is 15 by 4. So I have these numbers 7 by 2, 13 by 4 and 15 by 4. All these numbers are given here, and these numbers are the numbers easily I can have all these numbers. Clear? Now I can find also 5 numbers, 7 numbers, how many numbers we have been, so we can find as many numbers we want to. Another way of is making the denominators equal. For example, if we had to find out 3 rational numbers between 3 by 4 and 3 by 4 and 9 by 10. These are the two. So how to find? What is the way to find out the, let's say I will take it not so, I take it 5 by 6. So how to find the numbers between these two? It has 4 as a denominator, is at 6 as a denominator. So to make them equal, we have to take the LCM of 4 and 6. And what is the LCM of 4 and 6? Your answer is perfect. It is 12. So the LCM of 4 and 6 is 12. So 3 by 4 has to be made to be 12. So what I will do, I will multiply both the denominators and numerator by 3, and it will be 9 by 12. It will be 9 by 12. Now another one, 5 by 6. To make it, I will multiply it by 2. It will be 10 by 12. I have the numbers which is 9 by 12 and 10 by 12. But there is a gap between 9 and 10 is 1. So I will not be able to find out a number very easily, a number between 3 by 4 and 5 by 6. So to make them another one, should I multiply them by 2? So it becomes 18 by 24 and it becomes 20 by 24. So between them there is a number which is 19 by 24. This number is lying between these two. These are lying between these two. So I will take this as the first number, first rational number. This is my first. Now I have to find out the another one. So what should I do? Should I multiply them again by 2 or by 3? So let's say I will multiply them by another number, or I can again multiply 9 by 12 and 10 by 12 by such number which will give me 3 rational numbers. So directly what can I do? I can do one thing. Directly I can multiply 9 by 12 with 4. Okay, and 4, because I need 3 rational numbers. So I will multiply one more than one of that. I will get 36 by 1248, and I will get 40 by 48. So between 36 by 48 and 40 by 48, I have some numbers which is called 37 by 48, 38 by 48, 39 by 48. I have 3 different rational numbers between them, which is my need. I had to find out these numbers. I had to find these rational numbers between them. So this is another way of finding out the rational numbers between two given rational numbers by equating the denominators, making the denominators equal. Now another one question is there any name, I will take it is there any name given to this, this and this? What I have taken? I have written like this, 3 by 4, and I have written 9 by 12, and it is written 36 by 48, or is equal. Here 5 by 6, 10 by 12, 40 by 48, all are equal. Is there any name given, a specific name given to them? Is there any specific name which can be given to these numbers? Yes. The specific name given to them is equivalent fraction. Equivalent fraction. Equivalent fraction is a name given to these type of fractions in which the simplest form of rational number in the form of P by Q is when P and Q are co-prime. Now the question is, what is co-prime? The question answer is when two numbers have only one as common factor or divisor, then they are known as co-prime. It doesn't mean whether they are prime or composite. For example, 6 and say I will take 13. So 6 have factors as 1, 2, 3 and 6. It has factors as 1 and say 5, 1 as 13. So they are in between, they have only 1 as common. So they are called co-prime. 6 is co-prime with 13, or 13 is co-prime with 6, or I can say 6 and 13 are co-prime numbers. So this is the way in which if we just put any rational number in a simplest form means they are having P and Q as co-prime. For example, here this is not the simplest form, this is the simplest form. If I will cut, it will be 3 by 4. If I will just 12 3 times, 12 4 times. The simplest form is 3 by 4, 3 by 4, 3 by 4. Any fractions or rational numbers which can be represented when they are represented in the simplest form are having the same simplest form, then they are called equivalent fractions. They are called equivalent fractions. I will give you more examples. There can be a question like that. Make 5 equivalent fraction of 7 by 9. 7 by 9 is a fraction or a rational number. So 7 by 9. So 1 is 7 by 9, multiplied both denominator by this, it is 14 by 18. Another one, 7 by 9 is multiplied by 3 on both the sides, it will be 21 by 27. Another 7 by 9 is multiplied by 4 on both the numerator and denominator, it will be 28 by 36. 7 by 9 is multiplied by 5 on both the sides, it will be 35 by 45. Another 7 by 9 is multiplied by 6 on both the sides, it will come 42 over 54. So these are the 5 different equivalent fractions of 7 by 9, because the simplest form of 14 by 18, 21 by 27, 28 by 36, 35 by 45, 42 by 54 are same. They are same as 7 by 9. So they are called equivalent fractions. The fractions are also the rational numbers. Please remember, fractions are also the rational numbers. We have discussed that in our last class, in class 8. So let's do exercise 1.1. What are the questions in it? Just take your book and take exercise 1.1. In that exercise, what we have the questions, let us go with those questions. The very first question in that exercise is about, is 0 a rational number? Very easy question. Is 0, the first question, is 0 a rational number? I have explained this question in the last session, and the answer is nothing. Answer is yes, because 0 can be written as 0 by 1 in the form of P by Q. Can you write it in the form of P by Q? Yes, I can write in the P by Q form, where P, Q by integers and Q is not equals to 0. Yes, Q is not equals to 0. The first question is completed. Second one. Find 6 rational numbers between 3 and 4. Okay. 6 rational numbers between 3 and 4. How will you find? There are so many ways in which we can find, and one of the ways, the first number can be, the first is 3 plus 4 by 2, which is 7 by 2. Another one we can have, and I have solved this, I have just told you this, we can find out, but I will give you an idea. We have solved this question with the 5 rational numbers, with 3 rational numbers in our examples which we have solved previously. I will give you another way. One number is here 3 and another one number is 4. 3 can be written as 3 by 4 or 3 by 1, and it can be written as 4 by 1. I had to find out 6 numbers. Let me multiply sorry, let me multiply these numbers by 7, both numerator and denominator. The number is 21 by 7. This is 28 by 7. Now I have some numbers between 7 and 20, this as, the another number can be 22 by 7, the another number can be 23 by 7, 24 by 7, I just rub it, 25 by 7, 26 by 7, 27 by 7 and 28 by 7. So between these two numbers I have 1, 2, 3, 4, 5, 6 rational numbers. So this is one of the easiest way to solve, to find out the rational numbers between any two rational numbers. If integers are given and we have to find 6 rational numbers, just multiply them with the next integer, which is 7. So multiply numerator and denominator by 7, numerator and denominator by 7, we have 21 by 7, 28 by 7, and between these two we have a gap of 7, and between them there lies 6 rational numbers. This is one of the easiest way. Moreover, maybe it will be possible your answer is not matching whatever the answer is given in your book, but it doesn't matter whether it doesn't matter that you have done it wrong. No, because we have learned there are infinite rational numbers between two given rational numbers. So it is also, these are also the part of those infinite rational numbers. These are the part of those infinite rational numbers between two rational numbers. Clear? Let's go to the third question. Find 5 rational numbers between, third question says, find 5 rational numbers between 3 by 5 and 3 by 5 and the another one is 4 by 5. So multiply them with, I have to find out 5 rational numbers, so multiply them by 6. 4 by 5 multiplied by 6 by 6, so it will be 18 by 30, it will be 4 into 6, 24 by 30. So the next is 19 by 30, 20 by 30, 21 by 30, 22 by 30, 23 by 30. I can also denote them in the simplest form. These two are co-prime, so it is 19 by 30. These are not co-prime, so these will be cancelled by zeros will be cancelled. It will be 2 by 3. These are also not co-prime. It can be cancelled by 3. It can be 7 by 10. These are not co-prime. They can be again cancelled by 2. It can be 11 by 15, and it is again co-prime. So this is the possible answer for these possible 5 different rational numbers lying between 3 by 5 and 4 by 5. Clear? So these are the rational numbers lying between 3 by 5 and 4 by 5. Another one. How to find? Next question is state whether the following statement are true or false. Give reason for your answer. I have my book here. I'm just reading the question. State whether the following statement are true or false. We have to. Every natural number is a whole number. Every natural number is a whole number. I think it is it is true. Why? Natural numbers are 1, 2, 3, 4, 5 and so on. If I will add to them these natural numbers, if I add 0 to them, then they will become whole number. So every natural number is a whole number. That is perfectly true. Every integer is a whole number. No. If -1 is written, -1 belongs to Z, but -1 does not belongs to whole number. What we have to say? If somebody is giving us every integer is a whole number, then we have to go against that to make it false. If we are not able to make it like false, so it should be a perfect answer. -1 belongs to Z, but -1 does not belongs to W. That means it does not belongs to a whole number. We have gone against the way what the statement they have given. We have gone against that and we have proved it. So this statement is false. Again, every rational number is a whole number. Let's say whole numbers, every rational number. I will say 5 by 7 belongs to rational. But 5 by 7 does not belongs to whole number. I have given an example here which obsoletes what he is saying. He is saying something which obsoletes that. So these two statements are against whatever they said. Every rational number is a whole number. So it is again a false. The first statement is true. It is false. Second is false, and third one is also false. So this is one of the way in which we can make false and trues to the statement. Is it okay? So we have been completed with this exercise 1.1. After this, we will go to the next session in which we will deal with the irrational numbers. And again, irrational numbers are also the part of real numbers. We have discussed in first session. So we will discuss more elaborately in the next coming up session with irrational numbers. So have a nice time. Bye. Thank you.